We're back. We have to change the, there's no 3 in front of here. It's 2x squared minus 1, x third minus 216. The window is x min is 0, x max is plus 20, y min is minus 5, y max is 10. Graph it. You're going to get an asymptote at x equals 6. We can see by looking at the table of the graph. How do we find that? The asymptotes? The vertical asymptote set the denominator equal to 0. X third minus 216 equals 0. X third equals 216. X is the cube root of 216 is 6. And there we have it. See, it approaches 0, approaches 6 going this way, and approaches 6 going this way. And what about the y asymptote? The horizontal asymptote? Well, you look at the powers. This is n over here. Remember the first term. N is 2, and m is 3. So n is less than m. If you look at on your table that I gave you, that means that your horizontal asymptote is at y equals 0. And that is the end of that problem. That was a simple problem. The big thing is looking at the window, which I'm giving you. So the big thing has become a small thing. So let us continue with some more problems. Okay, so business number 9. Solve for all roots. And the equation is 8x squared plus 8x equals 1 minus 8x squared. Now the tendency here is to cross these out. It's not. When you bring the 8x squared over, you gotta add a plus. And I'm going to bring the minus 1 over here too. So you got 16x squared plus 8x minus 1 equals 0. Now when you see a 1 here and an 8 here and a 16, pretty much got to tell yourself, I'm not going to be able to factor that. So I'm going to use the quadratic formula. And once again, the quadratic formula works for everything. If you get integer values for your quadratic formula, you know it was factorable. Once again, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac. The whole thing over 2a. Some people just put the 2a over the radical. It's over the whole top numerator function. So let's see, well, what is a here? A is 16. B is 8, and C is minus 1. So let's see what we have here. Minus 8 plus or minus the square root of 8 squared minus 4 times A is 16, and times C is minus 1. Divided by 2 times 16. So x is going to be minus 8 plus or minus the square root of 64. That's interesting.
Mm-hmm.
We get a 0, which is all right.
Actually, wait, no, because it's 2 negatives, so it'd be 64 plus 64.
Oh, plus 64, that's right. It's 2 negatives plus 64 times 32 equals minus 8. Even if we got a 0 here, that would be okay because we still have a solution. If we got a 0 here, I didn't teach discriminant analysis, but if we got a 0 under the radical, it means there's only one solution. It's the same value.
It's a double root.
It'll be a, well actually it's a, both roots are the same value. So the, if this was 0, you would have a graph that looks something like this. You just touch it once, so all roots would be the same value. And that would be tangent to it. This isn't true. Okay, is that what I got? 128? Mm-hmm. Okay, I'm going to leave it that way and just have you finish it. Everybody knows how to do the quadratic formula. If I didn't ask for the simplest terms, you could actually leave it this way. But let's go on to the next one, because there are some things that you had problems with on the quiz, which I want to make sure that I get into. Okay, so we have number 10. We have the costs. We have a cost function is 100,000 plus 210x plus 2x squared. Something's going on outside here. All right, so what do I want to find here? I want to find the average costs. Well, that's C bar x. And the average cost will just be the cost function divided by x. So this will be 100,000 divided by x plus 210x over x plus 2x squared over x. So what do we get here? Our average cost, or our cost with a little bar over it, is 100,000 over x plus 210, all alone, plus 2x. All right, that is not a real polynomial function. It does have a graph like a polynomial. It has a little bit of a weird graph. All right, so this is the average cost equation. So B, find the average cost when x equals 500. So x equals 500. That's going to be 100,000 over 500 plus 210 plus 2 times 500. Okay, let me erase this down here. All right. So let's see what we get here. 500. So that's going to go into, that's going to be 200. 200 plus 210 plus 1,000 equals 1410. That's your average cost per unit. All right. Notice that's what average cost is your total cost over x. All right, it says graph the average cost function. Find its minimum value. So you want to graph this. I'm not sure if I've done this.
Hold on, wouldn't that be 400?
No, 5 was the 10 too.
No, I'm sorry. Continue. I'm sorry.
Yeah.
I need to have some coffee this morning.
Okay. Only on Tuesdays.
Going back to that social math again.
Yeah, right. Graph. So I want to graph this. The average cost function. Sorry, my zeros are terrible. This board also vibrates. Plus 2x. I'm going to put this in my calculator now, so just give me a minute. If I can find where my calculator is. Okay. Now the problem with this is finding a window. I always have problems finding windows which aren't drafty. These review classes always give me a good opportunity for telling really bad jokes. Okay, so this one's tough. To find a window, you would actually look at the behavior of this graph. As x increases, this decreases, but this increases. So what would our maximum, well, this couldn't be 0, because it would be infinity. So if x was 1, let's try to see what our maximum value is. X equals 1, be 100,000 plus 210. So about 115,000. So what I'm going to have to do is get my y window to be very, very large. So I put 20,000. The reason is I always go over. What do you mean quit? What is wrong with you? I probably didn't do something right. No, that's right. Oh, I see what I did. Uh-huh. Okay. Put a 1 there. Thank you very much. I changed my XC1 so it had different intervals, and that's why it gave me a problem. What did I want to do? I want to do... Let's see if this works. Yep. Okay. So here's my window. And I would give you the window for this on an exam, okay? Because I haven't taught you how to find windows. Actually, if you just go to a hardware store, I think you can get them. So here, so here we go, and the graph looks something like this. Let me change that window there to that X window. I think there's more on the other side. Let's change it to it looks something like this. Okay, this is what your graph looks something like. This is your average course graph. It's not completely symmetrical. I'm not drawing it right because my drawing skills suck. So this goes something like that. Yeah. So I actually extended my this window to 500 to get the other part of this. So now I'm going to have a minimum here. Now how do I find the minimum cost? Well, I can't do not use xv equals minus b over 2a. You cannot use that. That's only for polynomials. This is not a polynomial. This becomes almost a rational type function. So this is not a polynomial. There are no parrots involved. That was a joke too. Polynomial. Polynomial. That's a mathematical parrot. So we have to go to the graph. If I can find my graph again. Aha. Okay. I seem to. Oh, I know what I do. I have my scatter plot still turned. Sometimes you'll find some really weird marks on your thing, and what happened is it's a leftover scatter plot from a regression problem. So let's go to second trace and go to minimum. Okay. This one's a very difficult one to find, but you're going to find that you're going to get an X and Y here. I will do this in class because my window has to be different than this. Sorry about that. My window has to be extended all the way out, maybe this up to 100,000. So basically, I'm going to finish this in class. So number 10 I will finish in class on Wednesday. I just don't want to spend the time here fooling around with my window. Okay, let's go to another one. Basically,
we're at 17 minutes, just FYI.
Okay, we'll stop now and we'll go to the next. Okay.